All right, folks, how's it going? Hopefully, everyone is staying healthy and safe out there. My name is Nico Kavar. I'm a solution architect at Tegera, and today we'll be doing an overview of Calico and Kubernetes network policies, going through, what are networking policies, why you should care about them, how they work, and especially comparing and contrasting between Calico and Kubernetes network policies and when to use one versus the other. So if you haven't attended any of these sessions before, we try to host a couple of sessions, like 2 a week, to talk about all things related to Kubernetes networking, network security, and a whole long list of topics. This session is being recorded, so you can always go back to the recording on the same site, that is Tegera Events, as well as it will be uploaded to YouTube after the fact. So you can always go back and check it out if you missed anything. Also, feel free to raise any questions throughout the discussion in the Q&A or chat windows. I'll be more than happy to address those towards the end of this discussion. So let's get started. Again, I introduced myself. Been with the company with Tegera for close to a year now. Prior to that, I was at Docker and Cisco prior to that. Pretty much been working around containers and container networking and cloud networking for the past 10 years or so. Not the containers part, because they were not there 10 years ago, but for the past 4 or 5 years, I've been mostly dealing with Kubernetes and Docker containers. So if you want to reach out, feel free to send me an email. If I don't get to answer your question, I'm always happy to address those via email. So let's get going by kind of introducing Project Calico. For those of you who have not worked with Calico before, it's a community-driven open source project that started around the same time as Kubernetes. It is focused on delivering solutions for Kubernetes networking and Kubernetes network security, providing kind of the best-in-class pod networking, pod network security, and so forth. Although it began being a solution for Kubernetes itself, we have extended the power of Calico to be more than just that, helping also secure virtual machines and host-based workloads. So why many users use Project Calico today? It is simple, secure, and scalable networking solution for Kubernetes and beyond. It is blazing fast because it uses native Linux data plane capabilities, providing a simple and scalable layer 3 network without any encapsulation, if that is your intended design. There's of course some encapsulation options for you, but providing a simple, from a networking perspective, a simple solution, single layer 3 solution for pod networking is what makes it, blazing fast in terms of delivering the best networking plumbing for Kubernetes workloads. It is massively scalable, mainly due to the fact that under the hood, it uses BGP as a core kind of routing protocol for advertising the pod IPs and prefixes across the cluster and beyond. So really the scale of it is the scale of Kubernetes itself in terms of the number of nodes and number of pods that it can support. There's industry kind of standardization around using Calico for policy. All the major cloud providers, the managed Kubernetes services use Calico for policy out of the box, as well as been embedded in key on-prem or hybrid solutions and certified with others as well, as you can see here. Pretty much all the Kubernetes flavors, whether you're talking about upstream or managed Kubernetes or hybrid Kubernetes solution, have support for Calico, if not even shipping with Calico out of the box. Finally, there's some real-world production. It's been in real-world production scenarios for quite some time right now. We're aware of more than 150, 160,000 clusters that use Calico, powering close to 1 million nodes out there in the wild, as well as a lot of enterprise customers that are using Calico today. Which kind of brings us to this summary over for Tagera itself. So Tagera is a company behind Calico, and we're maintaining our project Calico and also help develop some of the key upstream solutions with STO as well. In terms of our Calico Enterprise solution, this is the enterprise solution that we have and we provide to address some of the more, I would say, more advanced use cases for enterprises. You can see here some of our key accounts, key customers that have been using Calico Enterprise and trusting us with some of their mission critical applications across various verticals. So as you know, just to kind of highlight kind of where you can run Project Calico, as I mentioned, all the managed public clouds use it, or you can opt in to use it on-prem, hybrid, upstream Kubernetes, and pretty much any Kubernetes flavor that you can think of has support for Calico as both the CNI as well as policy engine. So let's dig deeper into kind of the core discussion for today, which is around network policies. So before we kind of dig into why you should care about network policies, just kind of reminded that how Kubernetes networking model has been designed from the get-go. So Kubernetes network model is not a flat network. It is intended in the CNI spec that any CNI solution needs to provide communication between pods so they can communicate freely without using any NAT. That means that it has to be a flat network where all the pods are kind of created equally in the sense that they receive an IP address, they can communicate, and they have their own TCP/IP stack. Of course, due to the nature of application deployments on Kubernetes, there's that dynamic nature. You have you deploy your applications, your deployments. Pods get dynamic IP addresses, and they're ephemeral. It means kind of they're going to be living in this, only for the duration of that pod. And once the pod is either recreated, rescheduled, or terminated, the IP is going to be released. Therefore, there's a dynamic nature for how pods are scheduled and the IP addresses are allocated. In terms of the writability of IPs, in many instances, especially for on-prem, you have Kubernetes clusters have this locally significant IP sizes that are only kind of within the cluster. They're only routable within the cluster, and you use some type of NATing to send traffic or send traffic from the cluster to receive traffic from other services. Therefore, there is a sense that the IP addresses of pods are not going to be significant outside of the pods, outside the Kubernetes network itself. That's not always the case, but it is the case for a lot of Kubernetes clusters out there. So based on those kind of characteristics, or sorry, based on those facts around how Kubernetes networking works and behaves, there is, as I mentioned, out of the box, the Kubernetes CNI spec, expects the CNI to create the pod IPs and do the plumbing so that pods are reachable. However, in terms of securing the pod networking, that is not really, it is not being addressed at all the same time as the Kubernetes network itself. Therefore, there needs to be another solution to actually address the network security aspect of pod networking. And there, this is where network policies come in place. So because of the three key areas I mentioned earlier, there has to be a better mechanism and way to define network policies. And one, they had to be label-based. So we're not defining policies based on IPs. We're not defining policies based on other characteristics of the pod. We're basing it on labels and selectors, similar to a lot of things in Kubernetes. It has to be declarative in nature. That means that you're not going to be in the process of adjusting your policy based on other aspects of the deployment. You define the end state of what you expect the network to be and the network policy to be, and then Kubernetes and the CNI take care of the rest. Of course, finally, it has to be dynamic in nature. There shouldn't be any manual steps in the way. As you scale your application, you scale up, you scale down. All those changes have to be dynamic and not be something that an SRE or an admin or developer need to be worrying about. So to compare that and contrast it with, I would say, traditional approaches to perimeter-based firewalling, you can see here the list of how Kubernetes network policies are different than traditional network security approaches. I want to highlight three key areas where, one, where the enforcement needs to happen. In a lot of perimeter-based firewalling, the firewall, even if it is distributed, the enforcement happens either at the network layer once the network actually hits once the traffic hits the network, or it could be across the various, if an appliance layer that is becoming a bottleneck, and therefore there is a risk there that some of the intended traffic or some of the traffic that is not intended to be allowed makes its way to the perimeter firewalling solution before it actually gets dropped. And to contrast that with Calico's approach, or the Kubernetes approach, is that the enforcement needs to be as close as possible to the workload. It's actually being done. Calico does it at the virtual Ethernet, leaving the pod. Therefore, if it's not meant to be allowed, it will be blocked there without putting much risk on the network or even on the host itself. Second, there's a static policy model depending on IP ranges. Also, there's a lot of adjustment. There's change management that need to happen every time you want to introduce certain changes to those more static policies with the traditional method. And of course, with Calico's approach, those changes are being dynamic. As I mentioned, by using labels and selectors, you don't have to deal with using IPs or worrying about IPs, because those are ephemeral and those are dynamic. Finally, in terms of changing changes to the policies would be applied in milliseconds. If you're going to open up a port or change the scope of the policy, those would be distributed and applied and enforced in milliseconds, as opposed to could be minutes, or if there's a manual change management process, sometimes it could be weeks even to make that change happen. So those are some of the key areas that I would say are important for us to kind of look at and understand and see kind of the value of moving to a more cloud-native approach when it comes to securing the network with Kubernetes. So Kubernetes, let's start first by talking about Kubernetes network policies, how they function, why you should care about them, and how they work, with some examples, and then we'll switch to Calico network policies and do the same, and then leave some time towards the end for some question and answers. So the intention or the goal of Kubernetes network policies is to let admins or application developers define their network rules using the same deployment artifacts, the YAML artifacts or Helm artifacts that are being created or used by the same developers when you're defining the application itself. So what that means is that you're basically using the same approach from both the creation and the ongoing process to deploy and redeploy and change your application network policies as you would for the application itself. This would also translate to kind of using newer methodologies like CI and other kind of DevOps methodologies to both create, manage, and deploy those policies alongside with the application artifacts themselves. Kubernetes Network Policy itself has been supported with natively with the Network Policy Kubernetes API, I think since like version 1.6, 1.7. So it's been there for a while. However, it is, they're not really being enforced by the Kubernetes itself. They're being enforced by the CNI. So the API for them is available in Kubernetes natively, but the enforcement is done by the CNI. In this case, we're talking about Calico. If the Calico is a CNI or this being in policy enforcement mode, that means it's been its responsibility is to enforce the network policy is defined there. Policies are namespace scoped. That means similar to a lot of things in Kubernetes, you need to define a policy within that namespace, and that can be applied to to pods using labels and selectives. You can apply it to pods directly using the labels of the pods, or you can use labels of the namespaces, or even the IP side as for when you define the rules themselves. Of course, it's going to be applied using kubectl, similar to all the things that you use, or Helm if you need if you're using Helm as a deployment method for your policies. It supports both TCP and UDP, so you can use either rules to define either TCP or UDP ports when you're allowing traffic, and it can be used in both ingress and egress direction. If we're looking at it from the pod's perspective, ingress means all the traffic coming into the pod, and egress means all the traffic leaving the pod. And this is where the policy is being enforced. Therefore, this is key to remember that ingress is incoming to the pod, egress is leaving the pod. By default, if no policy is applied to a pod, all traffic is allowed to and from the pod. Because as I mentioned earlier, the Kubernetes network model expects that pods can communicate freely. Therefore, there's nothing really preventing any pod to talk to any other pod across any namespace, right? So that's kind of the default and expected behavior. However, once a policy is applied to a pod, only the allowed traffic in the policy will be permitted. There's a default deny, implicit default deny behavior that is observed once you apply any policy to that pod. Not to all the pods, but to that specific pod, there'll be a default deny. And therefore, you're going to have to open up using rules, you have to open up the traffic as intended. So let's take a couple examples here just to kind of explain or kind of reinforce what I explained earlier. So in this case, the left-hand side is the YAML defining this policy. The right-hand side is the scenario here where we have 3 pods or 3 deployment services, various roles, front-end, helper, and DB. And we intend here, what we want to do is make sure that we define a policy that would only allow TCP connections coming from the front-end pods to the database pods in this my namespace namespace. So we define the namespace here. We define the name of the network policy. It's being applied on all the pods within that with that label. So as we scale up or down, that will be taken care of. It will apply in the ingress direction. So any connection coming into the pod, coming from the front end pods will be allowed if it's connecting to TCP port 6379. And as you can see here, we have not really defined any other rule, but if the helper pod tried to connect to the DB pod, it will be denied because there's an implicit deny. So if we're not explicitly defining the allowed rule here, then it will be implicitly denied. So another similar example here, but in this case, instead of using labels for the destination of the egress rule, we're defining a CIDR. This is helpful in when we have destination IPs that we want to open up or allow the pod to talk to, but they don't belong to Kubernetes, therefore we can't use labels. So we can define a policy in this case to allow traffic going to this 172.18.00/24 CIDR. And as I mentioned earlier, by definition, because we didn't allow anything or didn't explicitly allow traffic to this other 10.10.10.0 CIDR, it will be blocked. So that is how we can use IP CIDR ranges or specific IPs in the policies. Later on, we'll see how we can actually do something slightly different with what we call DNS policies. But that's for now. You can just kind of emphasize that you can use CIDR ranges when you're defining the rules for your destination targets here. Another example here for a default deny. So it's a best practice to, when you're having, especially if you have a multi-tenant environment, multiple namespaces, projects, is when you create that namespace, start with a default deny or start with a local namespace allowed. So that means that all the traffic only is scoped within that namespace and only that namespace. But in this case, we're doing a default deny, we're blocking all the traffic, and then we're gonna open it up one by one. So you can see here that we're matching on all the pods in that specific namespace. And because we did not explicit any rule under ingress or egress, it means that everything is gonna be, or nothing will be allowed in either direction. So this is a good best practice, I would say. If not, at least do it per namespace. So when you create any namespace, the traffic is going to be only allowed within that namespace. So let's switch over and see how Calico Network Policies contrast and compare to Kubernetes Network Policies. I have to remind you that both are open source, right? Calico is an open source project that enforces Kubernetes Network Policies, and Calico itself has a type that is called Calico Network Policy. Both are open source. If you're using Calico, you can use either or, and here's why we're going to see why you would want to use Calico if there's a use case for it. So first of all, we have to mention that Calico Network Policies extend Kubernetes Network Policies. That means that there's a set of functionalities that Kubernetes Network Policies provide, and Calico provides the same but extends in a couple of areas that we're going to go through. First of all, it's going to require Calico for policy. So if you're using a different CNI, you cannot use Calico Network Policy. It's kind of like, it should be known by now, but just kind of stating kind of the obvious here. You can apply Calico Network Policies by kubectl or Calico Cuddle, which is the other CLI tool that we have to manage and interact with all things related to network and network security for your cluster. It supports policy ordering and precedence. So if you come from the firewall admin or network ACLOS admin, that policy ordering is really critical because the higher, or I guess the lower the number of the policy, the higher it is when it comes to when it's going to be evaluated and enforced. And as soon as you have a rule in there that allows the traffic, that means that it's going to be allowed. So it's really critical to have more granularity on how the policy itself is being ordered. So if you have multiple rules in the policy, it's really critical to do that. There's also support beyond layer 3, layer 4. So Kubernetes Network Policies support layer 3, layer 4. So IP-based and TCP/UDP-based rules. We have worked in creating what is called an application layer protection ALP that integrates with Istio and Envoy. So if you're using those, you can define a policy in a single place, a single policy, a single Calico Network Policy that has both layer 3, layer 4 rules, and as well as layer 7 actions. So you can say within the same policy, allow TCP on port 6379 and only for HTTP posts for the specific URI. That can be pretty powerful because it's basically having to deal only with one place to define a policy that can be enforced by both Envoy as well as Calico. As I mentioned earlier, in terms of how you can use Calico Network Policies, believe it or not, there's a lot of the customers I'm working with today, a lot of users use Calico Network Policies on VMs. So if you have Kubernetes clusters today and you want to protect workloads or you want to protect your application, but applications tend to be not fully on Kubernetes, there could be some services that are running natively on Linux, or bare metal, and therefore having a uniform way to define policy, cloud native way to define policy, and being applied creates a really good opportunity to consolidate the definition and the processing methodologies of how you protect your application. And it can be that kind of common language for protecting the application, whether it is running on a VM or on Kubernetes. Another great use case for this is actual Kubernetes control plane itself. So, services like kubelet and etcd and other services, if they're running natively, a great way to protect those is using what we call host endpoint protection, which is basically protecting endpoints regardless if they're Kubernetes or running natively on the host. Calico Network Policy support both namespace scoped as well as global scoped. So this is something that is not there in Kubernetes Network Policy. So if you want to define policies that apply to either all of the namespaces, regardless, so as you create new namespaces, the policy will be enforced, or selectively on certain names and selectively on certain namespaces using namespace labels. That way, you don't have to repeat yourself when it comes to defining some policies that are more generic and global in nature that are relevant across multiple namespaces. Another key thing to call out here is around what you can do within a room. So if you recall the earlier example, everything implied that there's an implicit deny, and then everything you have in the rule in the policy would be to open up or to allow. Is the kind of the action. In Calico, you can actually have allow or deny, so you can do an explicit deny for certain traffic types, as well as supplement that with either log it or pass. So if you want to log the specific times where the CNI is denying or allowing traffic, you can do that. Or if you want to pass so that you're not evaluating other rules on the policy, you can also do that. So it's a bit more granular than just allow. Finally, and I think is one of the most critical things to mention here is around how you can actually, or what are the target endpoints, I would say, to, or how you can actually define the policies here. Of course, you can use pod labels and namespace labels. But one thing that we worked on and is a functionality of Calico Network Policies is around using service accounts. And the reason why this is critical, because if you recall, if I am a user, if I'm an application owner, and I have the RBAC role to create a pod, that means that I am also capable and I have the permission to label my pod. Of course, there's different methods to use and kind of make sure that the correct set of labels is being applied using either open policy agent or whatnot. However, just because I have that ability to label a pod, that means that I can technically label it as I wish, and therefore, if we're using labels to define what this pod is capable of doing and how it could, what type of network access it has, there's a security risk around just purely using pod labels. One can, use a different labels and can escape the policy being enforced to that pod. By selecting or by using service accounts and service accounts labels are backed, and typically users are not the ones who create their own service accounts unless you're doing your own development and your own cluster. There's more measurement around RBAC for service account, and therefore it is a more recommended method to define network policies. You can define it and use it when you're selecting the pods, and by saying, hey, use those specific labels or use this specific service account label. So all the traffic coming from this service accounts or going through the service account can be used in conjunction with other types of labels. So that way you have that level of R-backed R-backed focus or R-backed method of defining the pods or the targets that you want to define in your policies. Finally, the Calico Network Policies are used as a foundation for some of the, what I would say, the Calico Enterprise Advanced Capabilities. This is not the core of the topic today here, but we wanted to mention them that we have an extensive set of advanced capabilities in Calico Enterprise, and we use Calico Network Policies for those things like DNS policies that I mentioned earlier, policy tiers, previewing, staging policies, the overall kind of workflows around policies, among the things that are based on Calico Network Policies. So let's take a couple of examples here. The first being a global policy. That's an attribute or value-added functionality of Calico Network Policies. One thing to note here on the left-hand side, the API version is not networking.kubernetes.io. It's projectcalico.org. So this is kind of the API group that you have to use in order to kind of unlock global network policies. This is the kind. Again, in this case, we're not defining based on pod labels, that we're defining the traffic based on namespaces. So we're applying it globally, and then we're saying this is going to be applied to all the namespaces with the color equals red label, and it's going to deny anything coming from all the pods with color equals blue, and coming from the specific namespace. So you have more granularity around defining a global policy when you can select based on namespaces and pods. And on the right-hand side, you can see that I'm using kubectl here to define or to get and work with and interact with network policies. So next example is kind of more advanced policy. A couple things I wanted to highlight is the ordering. You can, again, the lower the order, the higher its precedences, the more it will be evaluated first. So you can specify that in how it gets how the policy gets evaluated. You can do a deny action, not only allow, also deny action. And you can use a service account as part of defining either the source or the destination of the traffic that you're trying to deny in this case. So in this case, I want to make sure that anything coming from this specific service account will be blocked, and anything coming from this namespace, the green namespace, on the ICMP traffic will be logged. So I will not take action. I will just log it, and you'll see the logs and the CNI logs, which is most likely in the kubelet logs. Another example, this is more leaning around Calico Enterprise policy capabilities. So basically everything you can do from a YAML perspective, you have this is a snippet of the GUI, so there's more to it. So you have more UI capabilities to define and interact with and manage the policies. A couple of things I wanted to kind of highlight. We have the capability that is called tiering. So you have 3 tiers in here. Each column represents a tier. This is can be aligned to a security team defining certain global policies that are applicable to all the cluster namespaces, and those would be evaluated, enforced first before the platform team kind of define their own, before the application team define their own. You can also see here there's the word staged close to or next to the name of some policies, because we have a capability called staged network policies, where you can actually stage a network policy, collect telemetry around it, make sure that it is doing what it intends to do before you actually enforce it. Finally, you can see here that there is in the destination rule for this policy is we're calling out, we're allowing traffic to a domain-based, right? So, or subdomain, in this case, the Twilio. So in this case, given that Twilio is an external target, if one option would be to create an IP address or CIDR for Twilio, but that is a difficult thing to do. They might be changing their IP addresses and so forth. So it's a tedious thing and a security risk to use strictly IPs when you're defining policies. And therefore, we have a capability called a domain-based or DNS-based policies, where you can define the domain or subdomain that you want to allow. And Calico takes care of translating that and making sure that the pods intend to talk to that domain are allowed to do so. So this is more, I would say, more on the advanced side, and you can see here that if you have some use cases that belong to those, then maybe you can explore Calico Enterprise, and I'll have more information about that later on. So with that, I want to kind of leave you with some takeaways. I know I've been talking a lot here, so hopefully it's been helpful, but 3 key takeaways. Of course, Kubernetes Network Policies enable you and your application to declare segmentation, network security rules and controls to restrict access only to specified workloads, especially when this cloud native approach where you have to assume zero trust. You have to define your policies, given that there's multiple applications running, most likely in your clusters. Define zero trust and protect your application using Kubernetes Network Policies. Now, Calico Network Policies is a more sophisticated superset of Kubernetes Network Policies that include a number of advanced policy features, and based on real-world use cases that we have, created those features for. Finally, can't emphasize this enough. Calico itself, you probably heard this before, but it provides scalable implementation of network policies and a proven in every large-scale production deployment, yet simple to use and operate, both from a networking perspective as well as network policy perspective. So a couple of things I want to leave you with in terms of if you want to learn more on network policies, if you go to docs.projectcalico.org, there's an extensive set of use cases and policies and scenarios that you can learn from and play with. They're really great documents for you, some great examples and guides there. Also, I'll probably put this in the chat, an additional great resource. I think Ahmed from, I think he works at GKE, Google. He put together a nice repo defining different real-world scenarios for network policies and some a mechanism to get there and some of the samples of those policies. So I'll put that link in the chat window when I finish here. Similar to this event, we have at least 2 events a week, both in US and EMEA hours. So if you are interested, there's a couple of ones coming up. Feel free to sign up for those. They're free for you, and you can learn and raise some questions, or share them with your team, covering, as I said, multiple use cases and multiple topics there. Finally, if I talked a bit about Calico Enterprise. Again, for Calico open source, you can use it. Pretty much everything I talked to about today it's free for you. You can use it, experiment with it, and so forth. Some of the advanced functionalities are available in Calico Enterprise. Beyond just the policy aspect, there's a lot of things that are really cool that we're working on. So if you don't have the cycles to go through the installation of it and try it, we have a kind of hosted trial. So feel free to check it out at tigera.io/trial, and you can get yourself a setup with some labs so you can learn on the capabilities of both Calico and Calico Enterprise. So with that being said, I really appreciate your time here. Hopefully this was a helpful session.